In this video, we will define what torque is, how to calculate it, and some examples of torque in real life. So what is torque? Torque is the turning effect produced by a force acting on a lever. It is also called moment, which is represented as an M, and the equation that we use is that tau, or torque, is equal to M, moment, which is equal to R times F, where R is the perpendicular distance between the force and the pivot measured in meters, and F is the force in newtons. Torque also needs to have a direction specified as it is a vector. The direction is usually described in terms of clockwise or anti-clockwise about the pivot. And the units that we use are Newton meters, or N times M. Here's a diagram showing you where the force is perpendicular to the lever. So here's the force, here is the lever, and we can see a right angle here. The distance R is the distance between the pivot and the force, and this force would produce a clockwise moment. To work that out, you would put your pen along the lever and then you would turn your pen in the direction of the force, and you can see it would give you a clockwise action. Sometimes the force is not perpendicular to the lever. In this case, the equation then becomes that tau is equal to RF sine theta, where theta is the angle between the force and the lever. Here's a diagram showing you that situation. Because only the perpendicular component of the force is going to cause a turning effect, what we would need to do is find that perpendicular component, and that would give you F sine theta. So you can see our equation there is R, our perpendicular distance to the force, and then times by F sine theta. This parallel component of force does not cause any turning effect. Now, alternatively, we can think of it as being the perpendicular distance to the line of action of the force. So here is the force here. I've drawn in the line of action of the force in the green, and then I've got the perpendicular distance between the pivot and that line of action. So what I'm really getting is that R sine theta times by the force. Some examples of torque in everyday life. We've got a seesaw here. Each of these people would be producing their own torque. So I would have a clockwise torque from person 1 and an anti-clockwise torque from person 2. When the anti-clockwise torque is equal to the clockwise torque, that seesaw would then be in equilibrium. In the second example, we've got a door. So I've drawn in the pivot which lines up with the hinge, and you would have the line of action of the pivot being all along that dotted line. You've then got the distance R, perpendicular distance R, to the door handle, which is where the force would be applied. So that force is kind of coming out of the page. Another definition that we have associated with moments is couple. And this is when we have two equal but opposite forces acting on an object. So if we were to think about it in terms of the sum of forces, because they're in opposite directions, one would be the negative of the other. So the sum of forces would be equal to 0. But this object would not be in equilibrium as it would rotate. So you can see that it would rotate in a clockwise direction. So we could say that the object has a translational equilibrium. That is, it doesn't move up or down because those forces are balanced. However, it doesn't have a rotational equilibrium. The torque that would be experienced by that lever would be 2 times by R times F. That's the end of this video. To hear more, subscribe to Dr. J's channel for the latest in her physics tutorials. Thank you.